Here we're going to look at four examples of drawing sine wave transformations to help you with your homework or assignment. So here we have in the first one y equals sine x minus 30 degrees. So what we're going to do, in the same way we've done with the quadratics, is draw our base function. So our base function, I'm going to use each two lines up to be plus 1 and minus 1. So again, remember our main points are 0, 0, 91, 180, 0, 270, negative 1, and 360. Again, I like to draw the base function to help us visualize how the transformation is going to be. So if I look at this equation, the y equals sine x minus 30 degrees, the only transformation that's applied here is that I have to move right 30 degrees. So this one's fairly easy because what we have to do is basically our key points is shift them to the right 30 degrees. So in this case, 0, 0 becomes 30 and 0. This one shifts over. Everything shifts over slightly by 30 degrees. And then I just connect all the dots. And there you have your transformation. So again, your base form, y equals sine x. And then in red, you have y equals sine x, y equals sine x minus 30. For B, or for the next one, again, I'm going to draw in my base form to help me again visualize what the transformation is going to be. Oops. It doesn't need to be too neat as long as you get the main idea of what the form is. So again, this was y equals sine x. And if I look at my equation, the y equals negative sine x, the only transformation I see here is the minus sign. So the minus sign means it's flipped. So this means it's very similar to, say, something like a reflection activity that you may have done in elementary school or with a mirror. Basically, we use the x-axis as our mirror, and we flip everything to the other side. So actually the 0, 0 doesn't move, it stays there. This positive one now comes here, 0, 0 stays the same. 270 now goes up, and we see an inverted image of our sine wave, which is y equals negative sine x. So the red one is our transformation, and the blue is our base form. For B, B is going to be the same thing, or sorry, not B, C, or the third one, it's going to be the same thing. I'm going to draw my base form with the 5 key points that we've talked about with periodic functions. So this is y equals sine x. And I'm going to draw, or I'm going to figure out what my transformation is. Again, looking at the equation, the only thing I see is this minus 60 degrees. So again, that means I have to move right 60. So all of these points are going to be shifted to the right 60 degrees. Or basically, in this case, it's 2 spots. And I'm just going to connect the dots. And that is my transformation. For this last one is going to be a more complicated one because we have all 3 transformations to apply. But again, it's going to be the same pattern. I'm going to start off with my base form. Again, I'm going to label the sides again. Actually, we might have to change it. So each line is going to be 1. So this one may look a little different only because we changed the scale on the side, but we did that to help us draw this. So this is this blue one, y equals sine x, again our base form. Now we need to look at our transformation down here to see, okay, what things have transformed. Well, we have this one, the plus 30, which is actually means left 30. We have this plus 1, which means shifting it up 1. And the 2 means a vertical stretch by a factor of 2, or that the amplitude is 2. So again, I'm going to start with my first point, and I'm going to apply the transformations to that. So I know that I have to move it left 30 and up 1. So I'm going to go over 30 and up 1. I don't need to apply the amplitude because the midpoint doesn't apply for the amplitude. The next point does. So the next point, the amplitude actually needs to, or actually I'm going to move it left 30. So I move left 30, up 1. But because it has an amplitude of 2, I actually have to move it up 1 more. Because now this gives this first part an amplitude of 2 because it goes from 1 to 3. This 80, or this next point, it's a midpoint, so I don't have to do anything other than move it to the left 30 and up 1. Because now it comes back down. This 270, again, to the left 30, up 1. But again, to apply that amplitude, I need to move it actually down 1. Because again, we go, that amplitude needs to be 2. And finally, our last one, we go back 30, up 1. So there's our new graph. So we still have this amplitude of 2, and we have our main points. So y equals 2 sine x plus 30 plus 1. So again, this one was a little bit more complicated because we had the amplitude and the vertical shift and the horizontal shift to deal with. But again, treat it the same way as you would a quadratic transformation and follow the steps and you should be fine.